Hi, thank you for attending this session. We're going to be talking today about deploying with confidence to Kubernetes and all the pre-deployment tasks needed to do so. I'm Sergio Cardenas, the Monocle product leader at KubeShop, and I'm really happy to see you here. So why it's a challenge to deploy to Kubernetes? It's the next big thing. It should be easy, isn't it? Well, actually, it's not. It's a really complex thing. There's like 2,000 different tools part of the cloud native landscape, and there's a reason why. Kubernetes does a lot of things and try to be the cloud native platform for every type of workload. So it has to adapt to everything. But just selecting the components and the pieces you're going to be installing is hard. Just think that in order to be working properly with Kubernetes, you will be going cloud native fully. So you will try and install CI/CD pipelines. You will be working with microservice. Your application need to be rewritten in many times to be working, even if you can also mix uh, virtual machines and containers inside things. So if you're a developer, you're going to be needing a lot of technologies, and you need to understand that. You need to understand clouds and how they work. You need to understand containers. You need to be able to work with Amazon Azure and GCP under technologies. And also, you need to be working with automation. And on top of that, everything related to Kubernetes, that it has a lot of concepts on its own. And that's meant that your code is not only your code, it's more than that. This is your application configuration. So if you have your application, you're going to deploy it, it's going to have environment variables, you're going to have things that you need to configure how your application is running. But you're also going to package in a specific day so it can run on Kubernetes. So you need to define pods, you need to define containers in some way, and also you will have to realize how compute, networking, storage, and every other dependency is working. And think that most of it is written in YAML, those definitions. But if you're doing microservices, you're going to have a lot of components working together and being together to make it. And that complicates more things. And then you run them, and you need to configure how that thing is going to run in your Kubernetes cluster. So things like um, load balancing and the different options you have, the secrets, everything related to resource and auto scaling. Those are things that need to be taken into account when you're deploying your application to Kubernetes. So from all of that, we're going to be talking today about one specific thing, that is the management of your configuration. And that's basically done, as I said, in YAML files. But most of that, it's using a concept that Kubernetes called manifest. So what is a manifest? But it's roughly the specification of an API object in JSON or YAML format. It's going to define one object that is going to be there. And the moment the object is defined and it's pushed to Kubernetes, it becomes a record of intent. You want Kubernetes to have something, and Kubernetes will make everything will work all the time to make sure that the object exists with the configuration you define. So you're basically telling the desired state, and that's a concept we need to take into account. What is the desired step? And Kubernetes will work to make your desired step the real step, converging into it. So how do you do it? Easy. You can use three ways, actually. You can create directory using the API, where you use kubectl, the tool that gives you interaction with a Kubernetes cluster, and you create an object and you define the different pieces that come there. That's the easiest one, and that's what you have in every single one-on-one on Kubernetes. But that has a problem. There's not. It's really easy to use, but there's no evidence of what you have. So you can modify things. You can change the number of replicas. There's a lot of things you can do. Easy to use, very hard to maintain. So the next step will be creating and editing in your IDE one YAML file, and then push that YAML file. And that's way, way, way better, because that's basically mean you can use and reuse the configuration. What a lot of people do is copy and paste. Stack Overflow, just go any place, or you're using a powerful IDE, you can use templates or plugins or generators to have something to base upon, and then you basically modify what is there. Again, a little bit more complicated. There's more things, but it's open a lot of options, like being able to store that in a configuration system and then knowing what changes have you had done. And of course, you can do both all the time. You can modify things using the command line. The next step, you can actually use some other tools that I will be talking around, or you can generate different objects together using a folder where you store everything you have, and there's some ways to package and modify those informations before you push them into your container infrastructure. So what is the structure of a manifest? So there's 4 pieces that need to be there and you need to define. The first is the API version. So what is the kind of object you are defining? You have spot, you have services, replica sets, deployments. There's a lot of kinds that come together. And then you have an API version. So you can have different that. And this is an API. So the actual implementation, it's related, but not completely isolated. So one of the things that will happen is that you will have different version of this API in your cluster at the same time. We will talk more about that later. And then you have some metadata, basically a name, and the name need to be unique, at least a name in a namespace. There is an optional value of the metadata. But, and again, a namespace, it's a way of isolate workloads between one and another namespace. And also you can use labels and annotations with different end use. The key value, when the labels are used internally by Kubernetes to define things, like the scheduler use labels to know what it's doing. Load balancers know which object they need to load balance using labels. But also you can use annotations to put any metadata that you need internally for your application. So you don't need that to be part of the API and be used by Kubernetes. You can use annotations as an option on top of that. And then for each one of them, for every kind and every API version, you have the specific content that is defining the spec, and then depending if it's a service or a deployment or a pod, you will have different parts inside that. So how this works together? Just you have the schema, you have the kind, they define the way, they're using a JSON schema, using OpenAPI 3.0, when kind of certain limitation that everything is related. And all of this is YAML, so you have the properties, the types, the enumeration, the arrays that are part of YAML. You can see that every version of Kubernetes has a full team group of APIs that you can use with the different versions. And the way this works, it's, well, Kubernetes 1.25 will support different API version of the objects. And when you move from one to the other, you will have the same, or you will have new objects and new version of the objects. Important things, there's a lot of compatibility between one version and the other. So it's mandatory that you have the version that are supported in one version of Kubernetes will be supported. Or there's a translation that is possible between one API version and another API version, so your configuration doesn't break. But your manifest, your configuration can be obsolete. What other things are there? So many times the objects refer to another objects. They can be using name, they can be using labels, or they can be using objects itself. So for instance, you can have a selector in a service that is going to basically tell you what things are part of that service. And in order to do that, you use a selector that it's going to have a label and that label is going to be present in other places. So Kubernetes can make the link between one and the other. Or you can basically say, I need to have a specific group, API group, and I have a reference that specifies one object in the system. Again, all of this dynamic, very cloud-alike, and a very important relation because it's going to change the way your things are behaving. If you make a mistake and you're referring to a template or you're referring to an image and you misspell the name, your deployment won't be able to work. And all of this is the part of the configuration you use, but there's another part. Every time you push something into your cluster, Kubernetes will create a status property for you. And that includes everything that it's needed to know the state of your cluster. So when you probe and you ask about the state of your object, you're basically asking for the object itself, and the state is part of the definition of the object. It's not for all object types. Only some of them have this status and conditions. But it's also important because you cannot modify this part. This comes from Kubernetes, and if you try to modify them and then push back to do a change in the object itself, you need to keep this as it is, or it will basically fail. So how this works? I have that, it's in the state, it's in the cluster. So there's different ways I can do that. As I told you before, you can use kubectl, or you can use some tools in the middle, or you can automate it. One of the trends in the industry that is coming right now is that store all the information in Git. And then your continuous deployment pipeline will understand that has been a change in your configuration, and it will push the changes into Kubernetes. And again, there's two steps. First one, you push the new version Kubernetes. There's a controller that is constantly looking at the objects you created. And then if it's a difference between one and the other, it will trigger a change, and it will change the state until what is in Kubernetes is exactly what you have defined. That's called GitOps, and it's normally used in a DevOps environment, and it allows you to also understand what has happened in the past. You made some change, you can go back to the history store in Git or any other code source, and you can see what have the changes and what are expected. So how do you address this complexity? How do you make this in a way that allows you to deploy easily instead of trying and blindly modifying small pieces all the time? So the first thing is trying to find a way to make your manifest proper so they work. Even if they don't do what you need, at least they are proper and they have everything that is needed, so you are not walking around trying to fix some complex YAML file. So your configuration needs to be valid YAML or JSON. Even if YAML is easier to use and easier to read, so I would recommend using YAML. And there's different ways of doing that. You can use pure configuration, you can use templates, you can use kubectl generation to do that, or you can use templates. There's a lot of templates for different places. Helm, Kustomize, they modify the templates. There's ways of telling what you want to do, and yes, using Go templates or Jinja 2 templates, you can basically use variables in your configuration, or you can use an abstraction layer for application. There's some projects, part of the CNCF, external or internal, where basically instead of defining the objects of Kubernetes objects like deployments, you define applications and what they mean. Sometimes they're good because they are easy to use. Sometimes they are harder to use because you actually need to know what is going on in underneath if you're going to fix a problem. So every abstraction layer comes with a balance between being easy to use and being harder to maintain and harder to debug when you're having a problem. But there's a lot of projects out there because Kubernetes is complicated. The second thing is when you're using YAML or you're using JSON, actually it has to be YAML, but also it has to be a valid Kubernetes resource. So we talked before about the specific format and the different version of the schemas and APIs that you can have in Kubernetes. So it's important for you to get the proper objects with the proper definition and make sure that your configuration files follow the schema defined in the API. The CNCF basically recommends every time you create a new file, you use the latest version of the API, because if you use another version or an alpha or beta version, that can be deprecated, and then your configuration will be able to, you won't be able to deploy the same configuration in one version of Kubernetes and all the future version of the configuration. So it's important for you to take that into account. And when you're upgrading your cluster, verify that your schemas are still applicable and are still usable in the new version of Kubernetes with all the pieces and values that you need. And also, if you're referring to another object, you're using links, make sure that those links exist. And if you update one of them, you change the name of an object or you change a reference, make sure it changes in every place. So you're getting the expected result and not something unexpected, because you're basically only updated part of the reference in some of the deployments. That's the base thing, and that's really important, but also you need to use something else. There's a lot of best practices that they are not covered writing configuration files. They can be valid, but you need to do the things. There's some things that are optional, like using labels. Which labels are you using? Or the way you allocate resources, or the way you configure the network. Those are things that are optionals. You can deploy them in the way you want. So there must be a way to make sure that those pieces are in place. One of the most used open source project for this is Open Policy Agent, that allows you to define all those rules in a language called Rego, and then the Open Policy Agent will apply as part of your deployment process those rules. There's other alternatives. You have Kubernetes, you have the pod security policy that is deprecated. So there's a lot of projects that do something similar. But the good thing about OEPA is that there's a lot of predefined rules available. So you can go to GitHub, you can search on the internet, and there's basically people that are sharing their Rego policies, so you can copy and paste them and modify them. And also, there's plugins for VS Code that allows to define those rules easily using a Rego plugin. That make it quite easy to use. If you don't want to use Open Policy Agent, you can use others like Kubernetes, that is really something also very used in Kubernetes. Another way you can do to simplify that is using templated. So instead of writing things from scratch, you can use some kind of template and then generate the resources from the template. So you know when you're generating a good template that is going to work as appropriately. And that also helps you do something that is quite hard when you have a very diverse environment that is promoting from development to stage or to stage to production, because you can actually use the same templates, modifying the values that change those things. As always, in the CMFF, there's different ways of doing that. You can use tools that modify the YAML directory, like Kustomize on YQ, or you can use tools that use custom templates. They define a language and a way to use it. Using JSON.NET, Tankadeb, or using Helm, you define a template in a language and then a value file that will modify that. Or you can basically use tools that will generate it from code. You code what you need. One of the tools most used is Helm. And Helm, it's a project that combines templates from resources, configuration values, and some metadata to create what they call a chart. And what it does is you can deploy different elements using those templates in a single place. You do Helm chart install, and it produced the Kubernetes manifests and it deployed them to a cluster. Another good thing of using Helm is that when you deploy that, it will know what you have deployed. So you can update and you can do install the objects using the Helm chart and the instance as a way of knowing what is going on, and they can be parameterized. You can have in your default configuration values, you can define what values can be changed. So you can do in the command line or any tool that you use to deploy Helm charts, you can define those values. So you can change the number of pods, or you can change the labels, or you can change some of the things. The way these are consumed is also quite powerful because Helm allows you to package things. So you can have a Helm repository where you have different charts with different versions, and it's easy to add them to your local system, search the chart that you want to install. Many people publish Helm charts in Helm repositories, and then when you find them, you can download them to local and install them. Or another thing that is happening lately is that Helm now support OCA-based registry. So you can, if you have an OCA-based registry, you can store your Helm chart definitions into that registry. You don't need to use a specific Helm repository, although both right now are supported by Helm. If you don't like that, you don't want to do that, there's another alternative that is actually part of kubectl, the command line for Kubernetes, that is Kustomize. And Kustomize is a native configuration management system. What it does is use templates, but not to define the object itself, but to modify them. So you have a base layer, you can have different layers on top of that, and a customization YAML file that will tell you which files are being used and what are the modifications that you want to do on top of that. Good thing about Kustomize is part of kubectl, or it can be used as standalone. And also that you can use the same object. So you can use the same object for production or development, just changing pieces of that, because your customization YAML file can be an overlay and it can refer to a base customization file or to a group of files. And then, for instance, you can use a replica count YAML to modify the number of replicas in your final manifest. So it works as you expect. And you can have only that difference between production and development while keeping the base structure the same. Both approaches are good and they're used. Sometimes it's not enough. So one of the things you can do is use Helm and then package your application using Helm. So your application packaging, your application config is defined in Helm. That allows you to do have variables and modify them. But your runtime config can be a customized patch. So when you need to change the labels or you need to change any of the parameters that are specific to your environment, or security or the secrets, you want to create the specific secrets, you can basically use both of them. Use Helm and then use Kustomize to modify the output of the Helm chart to generate what you deploy to your cluster. At the end, what you're going to have is a tool where you generate a version of your configuration directory using any IDE, using Helm or using Kustomize at the middle. But you're going to have that. Then you're going to make sure they're right, using all the validations with plugins or with the specific things that go there, also in the cluster. If you're using policies. Of course, if you are using GitOps, you will be making sure that you can compare what happened in one version and the other, and that's a lot of guessing and a lot of eyeballs, but just think of that. If you're using Kustomize as an output of Helm, well, you will put some values file in your Git environment, and there will be a process until you have the real thing. Or there can be a different, because things like Argo, that is one of the most used continuous deployment environments, well, use also Kustomize to modify what you install. So whatever you have, you need to know what is the difference between what you're trying to do, your desired state, and the actual state, and you want to make sure that you can compare and know what are the difference of one and the other. Once you do that, you will commit it. We said it can be directory, can be using the kubectl, can be using Git and some CD tool. Some people use Git directory using hooks and they don't use a continuous deployment tool. But at the end, you commit and you hope that it's right and it's right at the first time. So you wish and you hope that it's working as expectedly and you verify that it's doing. And that's the last time of your environment. It's what happened when it's in place. You basically look at it, inspect it all the time, make sure that nothing is affecting any change on the infrastructure, any change of the configuration that you need this to work will basically affect it. So you oversee and you make sure you're inspecting all the time the behavior of your application. In many cases, you're changing your Kubernetes version, you're installing some new tool of the 2000 tools in the landscape, you're changing the way you want this to behave, or you're lucky and you need to generate a lot more capacity for your workload. You have to modify that configuration and you will go back to the generate phase. You continue doing this, trying to be agile and making that working. I'm part of Monocle, so just to be sure, there's ways to do this properly. Monocle allows you to generate, validate, compare, commit, and inspect what is happening. So we have tools that will help you do all of this and will accompany you during all the process. Just to sum up, what are the best practices for this? So first of all, you need to understand your manifests and the life cycle, how they work. Use YAML because it's more readable than JSON. Even if JSON is approved and you can use it, YAML is better. Use the latest stable version of your API for all your manifests are doing. Just make sure they're there. They will be supported at least 3 versions if you are using the latest version. And be careful when you are using alpha or beta versions because they can be deprecated in the future. Keep manifest simple. And don't specify default values if they are not needed. Don't make people have to think of a lot of variables and try to understand what you're trying to achieve. Make it as simple as possible, even if you have to modify them later. And of course, define policies for your project, for your teams, that allows you to make sure that you have the proper resource configuration and metadata. Not only that, but use templates when you need them, and validate them and the output of them before you deploy merge as part of your CI/CD. Don't wait until they are in the cluster because you can break things. You can make things not work appropriately. So make sure that your cluster is working. Also, the CNCF tells you to use labels, and I think it's a very good thing because they are always needed. Using labels, it's a project in itself because you need to define specifically what labels mean, and that can be challenging too. But they are needed for introspection, they are needed, and you have to have them if you want to know what you did a few weeks back and you want to make sure that you can do that. And of course, adopt GitOps. But adopt it properly. Everybody needs to understand that if you're adopting GitOps, you won't be able to go outside of the tool to do it. And use whatever tool that fits in your workflow and make your teams productive. It's really hard to get everybody knowing what is going on. You want to see this process in action, you want to see how this works, and you want to see Monocle. We have this in Islamabad in February 16 from Code to Cloud. Just go there. I will be presenting along with Erdi. We will be together showing Monocle and all this process in context with a real application running. So thank you for listening. Any question, please reach to me. I will be very, very happy to have you. We have a Discord. You can go to monocle.io and we will be able to get in contact. So thank you very much.